Hi everyone, Miss Barber here for the last little bit of the 5.1 day 1 notes where we're talking about transformations of quadratic functions. So for number 4, it says the parent function x squared is reflected across the x-axis. So that's the first thing they told us to do, reflected across the x-axis. They want us to horizontally stretch it by a factor of 3. And then lastly, they want you to translate it 2 units down to create the function g of x. So let's now break this down one by one. So the first thing we're going to do is reflect it across the x-axis. If you look at the rule for reflecting across the x-axis, the rule will tell us to reflect across the x-axis, you have to put a negative outside parentheses. So it's going to be, or no parentheses at all. So to reflect across the x-axis, the first thing is going to be negative x squared. Negative, not in parentheses, to reflect across the x-axis. Now, step 2, I'm going to keep the negative x squared that I started with. So that's not going to change. But what is going to change is to horizontally stretch by a factor of 3. Horizontally stretch, if you look back to the first page, I'm going to have to put it in parentheses because I horizontally stretched it. Horizontal is always in parentheses. And because I'm stretching it by a factor of 3, remember you have to write it as 1 over what you're doing. So it's going to be 1 over 3. And then I can put back in parentheses. Squared always stays outside. So that's step 2. Step 3, we're going to carry all of my steps from previously. And now lastly, I'm going to translate it 2 units down. Vertical translations up or down are not in parentheses, and you just do as is. So rewriting everything I have negative 1/3 x squared. And to go 2 units down, it's going to be down 2, minus 2. So my final answer, because they want me to call it g, would be g of x equals negative parenthesis 1/3 x squared minus 2. So number 5 is similar. We just need to, again, follow the directions. So first, it wants me to vertically stretch by a factor of 3. Then I'm going to translate it 4 units right. And then finally, I'm going to go 2 units up. So starting, I'm going to take x squared and vertically stretch it by a factor of 3. Vertical is not in parentheses, and you do as is. So the rule just says ax squared. So in this case, I'm going to write 3x squared. That's my a. I vertically stretched it by 3, so 3x squared. The second part, it wants me to go 4 units right. Well, going right, that's a horizontal, so I know it's going to be in parentheses. So now I have 3 parentheses, x squared. To go right, you have to do the opposite. Horizontal is always in parentheses, do the opposite. So it's going to be minus 4. So I carried my 3, factor of 3 from the first, and then I have to do minus 4 in parentheses to go right. Lastly, my third step is to go 2 up. Well, 2 up's vertical, so again, you just do as is on the outside of parentheses. So carrying what I have through, I have 3 parentheses x minus 4 squared. And lastly, they want me to go up 2, so I just do plus 2. Again, it wants me to call it g, so g of x equals 3 parentheses x minus 4 squared plus 2. It wants you to write it in vertex form, which is what this is. You'll learn about what that is a little bit later. Number 6, a ball drop from the top of a tower A can be modeled by the function h of t equals negative 9.8 t squared plus 400, where t is the time after the ball dropped and h of t is the height at that time. A ball drop from the top of tower B can be modeled by the function h of t equals negative 9.8 t squared plus 200. What transformation describes this change? What does this transformation mean? Well, that's a lot of words, but just looking at my 2 equations, I have negative 9.8 t squared plus 400 and negative 9.8 t squared plus 200. So the only difference between them is plus 400. In the first one, h of t, and the second one is plus 200. Well, adding something at the very end is a vertical translation. So what this first one meant is you were dropping it from a tower at 400 feet. The second one, you were dropping it from a tower at 200 feet. So what transformation describes this change? You went down, which is a vertical shift, down 200. From 400 to 200, you went down 200. And again, that's a vertical shift. Last one, number 7. Not last one, but number 7. During a flu epidemic last year, a public health official determined that the number of students infected by the flu virus can be approximated by the function f of t equals negative t minus 23 squared plus 625, if t is the number of days after infection. This year, there's a new virus that can approximate it by, and here's my second equation, f of t equals negative t minus 25 plus 625. What kind of transformation describes this change? Well, again, look at how they're different. The only difference I see is minus 23 versus minus 25. Well, remember, minus in parentheses means you do the opposite horizontally. So the first one was plus 23, or 23 to the right. The second one would have been plus 25 to the right. So what kind of transformation describes this change? You went 2 more to the right. So that's all it wants to know. How did it change? Lastly, circle the function that produces the widest parabola. So in order to do this, we need to be looking at our a's, because remember, ax squared, a tells you your vertical stretch or shrink. The bigger a is, the skinnier it's going to be. The smaller a is, the wider it will be, not including negatives. Remember, the negative is a reflection. It has nothing to do with how wide or skinny or narrow a parabola is. So in order to produce the widest, we're looking for the smallest a. Well, let's compare all of my a's. Here a is 2, here a is 1/5, again, ignoring the negative, and lastly, a is 2 for this third one. So which one's the widest, which would be the smallest, would be g of x. So that's it for 5.1 day 1. Thank you for tuning into the second video. I hope you all have a great day.